Alright, today in Algebra 2 we started off by going over the unit circle that you guys worked on Friday. So here's the completed version. If you go around, you can see the degree measures are all here, okay, from 0 to 360. And then we also have that repeated with radians. So I have 0, pi 6, pi fourths, pi thirds, pi halves, and so on. The coordinates here are the x comma y, and you guys talked about how that's really just the sine and cosine. So if you look right here, if I were to drop down straight from this point and look at this triangle here, so this is 30 degrees. And this distance here is some distance x, and my height is some distance in the y. And then this side right here is just a radius of the circle, which is a unit circle, right? So my hypotenuse is just 1. Okay, for this angle, if I kind of finish this as a triangle, for this 30-degree angle, this y value would be the opposite side, and the x value would be the adjacent side. So I can think about the trig properties, right? So sine, right up here, sine theta, remember that's just opposite over hypotenuse. So for this angle here, that would be y over 1, which is just y. Okay, and then same for cosine. We have cosine theta. That's going to be equal to adjacent over hypotenuse. So in this case, the adjacent side is just whatever x value it is over 1. So it's just x. And this continues for all the other triangles as well. So I'm going to go ahead and erase this really quick. Go back and pause if you need that. But if you look right here, I could do a different triangle. So if I could want to look at this triangle with this angle, okay, this is now 45 degrees, or pi over 4. Okay, this is still a y length, this is still an x length, it's just these coordinates now. Okay, so again, cosine is just whatever that x is, and sine is whatever the y is, because this hypotenuse is still 1. Okay, so we just kind of looked at that. We went all the way around and checked the values, so please do that now if you missed today and you have your unit circle. We also talked about some patterns that we saw. So we noticed as we went around to 180, we had different values for sine, and then those same values repeated on the second half. They were just negative. So we had positive values on the top, negative values on the bottom, and they were the same, right? They repeated. There's also another little pattern if you look just in the first quadrant, if you focus in here, between 0 and 90 degrees. If you use this pattern 0, 1, 2, 3, 4, divide them all by 2, and take the square root of what's on top. Okay, so this one is just 0, right? Square root of 0 is 0, divided by 2 is 0. This one, the square root of 1 is 1, so that's 1/2. This I can't really simplify, it's just rad 2 over 2. This one is rad 3 over 3. And for this, square root of 4 is 2, so 2 over 2 is just 1. Okay, and you can see these are exactly the values of, this is 0 degrees, this is 30 degrees, 45, 60, and 90. So the first 5 significant values, you can remember it this way. And that pattern also repeats, so it goes up 0, 30, as we go around here, right? 0, 30, 45, 60, 90. And then it repeats again on this side, right? Because these 2 points have the same y value. Okay, so it goes 0, 1, 2, so 0, 1, 2, 3, and then 4, right, the rad 4 over 2, which is just 1. And then we go back down, so 3, 2, so that's over 2, 1, and then 0 again. Okay, so that might help you to remember those values for sine. What I had students do after this was in their groups, they completed the back side of the unit circle, which has a chart for, let's clear this, it has a chart with theta, and then sine theta, cosine theta, etc. We just focused right here on theta and sine theta, so not so much on cosine yet. And I had them fill in the values, so I'll show you what the completed version of that should have. Okay, so here's the table that you should have. It's a little smaller than the table you have in your on the back of the unit circle, but this is the same values, okay? So make sure that yours matches up to this. What we did next was use these as x and y coordinates to plot the points in order to graph the function y equals sine of x. Okay, that's our main goal for the day. Just to be able to know what this looks like, okay? So for the axes, I went ahead and I looked at the different y values first. So I see the biggest y value I have is a positive 1, and the smallest that I have is negative 1. So I made my scale on the y go up to 1, and I really spaced it out so that I could make sure to kind of get accurate with the decimals in between, and it goes down to negative 1. Okay, the x-axis is a little bit trickier, so I don't really want to do like, oh, this is 1, this is 2, this is 3, and so on, because my x values that I'm going to use are radians, okay? We're going to use the radian measures, and that's kind of hard to think about, like, okay, so pi over 3, well, that's like a little more than 1, right? So it's a little harder to think of that way, so instead we're just going to label our axis using the radian measures, okay? So I know the furthest I'm going to go is 2 pi. I kind of broke this up into the 4 main ones first. Okay, so these are each 90-degree rotations, right? Pi halves is going straight up and down, right? Right here, it's 90 degrees. And then, so yeah, pi halves is right here, 90 degrees. Pi is 180 degrees. 3 pi halves is 270. And then 2 pi, we're back up here at 0, okay? So those are kind of the key ones. So I started there. If you're on graph paper, I would leave 3 boxes before you go to pi halves, at least 3, or like a multiple of 3, like 6 maybe, to split it up evenly. So what this will do is if pi halves is 90, oh, sorry about that. If pi halves right here is 90, then these in between, if I cut it into thirds, those are each like 30 degrees. So the first one is 30 degrees, which would be pi sixths, and the next one is pi thirds, right, 60 degrees. Okay, if you look on your unit circle, you'll see these measures and how they kind of evenly break up between 0 and pi halves. You'll see pi sixths is like this, and then pi thirds is right here. But there's one right in between those two. And if you look, you'll see that that's pi fourths. So we're going to put that right in between these two. Okay, remember, like I said, we're like cutting this unit circle and stretching it out to be a line. So let's undo this, and then we'll go ahead and label these. So the one right in between, oh, a little too far there. Okay, the one right in between, we want to call that pi fourths. I ran out of room down below, so I wrote mine above, but if you space yours out a little more, you could write them all down below. Okay, and I'm just going around doing the same thing. So looking here between pi halves and pi, these two split it evenly, and then, little smiley face, these two split it evenly, and then the 3 pi fourths is right in the middle of those two. Okay, and same thing here in the third quadrant as I go from pi to 3 pi over 2. 7 pi over 6 and 4 pi over 3, split it evenly, and then 5 pi over 4 is right in between those two. Okay, and last quadrant here, we get the same thing. Okay, so what I wanted you to do in class was to plot these points. So you would plot, let's say, 0, 0 first. So that's going to be this point right here. A little more clear. Okay, and then the next point would be pi over 6, comma 1/2. So that's just 0.5. Pi over 6 and 1/2 would put me right here. And then the rest of these, let's undo this, sorry. Okay, these I would probably want to think about as decimals. So right here, root 2 over 2, if you use your calculator, you can see that's 0.7. And root 3 over 2 is about 0.86. Or 0.87 rather. Okay, so you could use those as estimates, and it repeats many times throughout, right? Okay, so continuing to make our points, pi fourths would be at root 2 over 2, which we said is about 0.7. So that's about right here. Pi thirds is about 0.87, so a little bit higher still, maybe right here. And then pi halves is 1. So pi halves, I'd go all the way up here to 1. But then my pattern kind of goes back the other way, right? At 2 pi thirds, I'm at root 3 over 2 again. At 3 pi fourths, I'm at root 2 over 2 again. And at, oh, this should be a little higher, actually. Let's go back. Pi fourths here. Oh, no, that's right. Sorry. So pi fourths, we get about 0.7, so it should be right in between those. Okay. So then coming back down, we are here, and so on. Okay, so when you get this finished, so that was pi fourths, pi 6, and then pi is 0. You'll notice the curve that you end up with looks somewhat like this. Let's see, at 3 over 2, let me pause here. Alright, so here's a student example, and you can see, so this is what they have when they plotted all those points. And you see that we can kind of trace a general kind of curve. Oh, sorry about that. And that's kind of what our sine function looks like. So now that we know that, we can kind of use a little bit of a shortcut. If we focus right here on these main points of 0, pi halves, pi, 3 pi halves, and 2 pi, we can use what I like to call is kind of like the shortcut method. So I make at 0, I just plot these 5, and then I remember the general shape. So I know sine of 0 is 0, sine of pi halves is 1, sine of pi is 0, sine of 3 pi halves is -1, and sine of 2 pi is back at 0, and then I just kind of sketch a general curve. Okay, so that's kind of a shortcut way to just quickly have a graph from 0 to 2 pi for sine. Okay, so after doing that, we went ahead and graphed on Desmos. This is just a screenshot, so bear with me here. In order to graph y equals sine x, like this, you need to type y equals, so you hit the y button and equals, and then you hit this button here that says functions. Okay, and that'll pop up a menu, and it'll give you the option to hit sine, and then you just hit type X and end the parentheses, okay? Something that I also did was change the step. Okay, you'll notice if you do this on Desmos, originally it'll just say like 1, 2, and so on. And the graph will kind of be, it won't hit in nice places, I guess. So with this, I changed the step so that I can see, oh yeah, it hits at pi, and at 2 pi, the length of this period, right, of one period for sine is 2 pi. I can see that very clearly. So if you want to change the step, you just need to click here on the wrench, and then where it says step, you'll type down here you'll hit the pi button and then divided by 6. Or you could do like pi fourths if you want to do that. I did pi 6, but I was actually too zoomed out, I think, for it to actually show the markers for the pi over 6. So yeah, we just looked at this, and if you look here, okay, so here, kind of a zoomed out version, just focusing on the graph, you can see how sine x is a function that's periodic. It just repeats, so every 2 pi, the same pattern happens again and again. And that has to do with the fact that we're rotating around. Think of the unit circle, right? We start here, we're taking all the values around here, and then if we go again, we're just repeating, right? We're lapping ourselves as we go around the unit circle again. So that's part of the reason why that's the reason why it's periodic like that. And that's what it looks like. So that's basically all that we did today. I know it sounds like kind of a lot, but it's really just this one idea of how we graph these trig functions. And you'll definitely see these more as you go into advanced math or calculus and any other classes in your math career. This trig stuff is definitely going to come up a lot more. So thanks for watching, and I will talk to you guys tomorrow. Thanks. Bye.